Can you guys hear me? The mic is on? Okay. Okay, let's get started. Welcome, everybody. I hope you had a first great day. You've been enjoying it so far? Yeah. Cool. So this session, I guess, is called Happy Hour, right? It's the last session of the day, and we have a very nice topic. And I think I have two things to show you today, which nobody has seen before. So I hope you will enjoy that. My name is Boris Scholl. I'm a program manager with the Visual Studio Azure Tools team. On that team, I own the diagnostics experience for Visual Studio when it comes to Windows Azure. So you can think about, okay, should we build a debugger for Windows Azure? Should we build live tracing and this type of stuff? Or also like lighting up IntelliTrace and profiling. In addition to that, I own the publishing experience, and recently I took over the developer dev test scenario from Visual Studio. I'm here today to talk about debugging and troubleshooting Azure applications using Visual Studio. And so one word of caution, I'm not going to talk about how to troubleshoot an application running on IaaS. Okay. Oh, sorry. We can try after the session. So the agenda for today is I'm going to give you a brief overview of like what is a cloud service. For those of you who have worked with cloud services, it's just a refresher or reminder. By the way, how many of you have worked with cloud services? Oh, wow, that's the majority. Okay, cool. So I think there's also something, you can think about it as a refresher, and then we go a little bit deeper into that topic and why that architecture is important when it comes to diagnostics. So then I'm going to talk about cloud services and Windows Azure Diagnostics in particular. How many of you are using Windows Azure Diagnostics? Okay, quite half of people. How many of you have heard of it? How many of you have had problems with it? Okay, good. So we'll cover that, and the way I structure the session is we have lots of demos, right? But I'll also give you like an overview how Azure Diagnostics, for example, works. How does IntelliTrace work? How does profiling work? So as a goal of that session is not just to show you a bunch of code and put some trace statements in there and see how you can basically diagnose your code. As a takeaway of that session, you should really understand the concept and benefit from it and basically take it with you and apply it. So once we covered Windows Azure Diagnostics, I'm going to talk about IntelliTrace and why is that useful, what you can do with IntelliTrace. And then we talk about profiling. I have demos prepared for IntelliTrace and profiling as well, but I cannot promise that they work. So I have a recording in case, so you will see that. And then at the end of the session, we're going to talk about Windows Azure Websites Diagnostics. How many of you have looked into Azure Websites? Right, yeah. Quite a few. So I also have a demo on that, how to do live tracing, and then in the end of the session, I'm going to talk about the Visual Studio Developer Desktop. That's really an announcement which will go out tomorrow. The image went live, but what we've done is we basically give you a Visual Studio MSDN licensed image on an Azure IaaS VM, and you can spin off a development environment right away. So that's the big news, the first big news. Okay. All right, so let's get started. I mean, we have in the product teams, we're getting a lot of escalations about cloud services, issues with cloud services, and we identified 3 high-level buckets, right? First of all, what we've been seeing quite a lot, I mean, we've been improving that over and over again, are really environmental differences. So a lot of people we talk to, customers like you or coworkers and internal customers, a lot of people really experience issues with the emulator. How many of you know what the emulator is? How many of you use it? Okay. So it's really, I mean, you've probably been in that situation. Hey, everything worked locally. I have F5'd it. Everything was fine. Then I deployed it to Azure and it didn't work, right? So I think there are a lot of those issues. Then there are performance issues. So for example, the site loads slowly. You never know what is the reason, right? We've been asked a lot, hey, what's the reason? I don't understand that. Is it my code? Is it the environment? If I have like, let's say a web role with 4 instances, am I only running on two instances? What is it, right? That's also a common issue we've been seeing. And then computation takes a long time. So for example, hey, I have worker roles, I put everything like my computational task on worker roles, I give it a lot of horsepower, but it's still not working. And the last bullet is really like logical issues in code. I mean, the most prominent one is really configuration mismatches, right? So if you think about, you have a development environment, I'm really talking about a local development environment, and then you deploy or publish to Azure, and then you forgot to change the connection string, or you don't have like another CSCFG that points to a new environment, right? That's one of those examples we're getting. Do those issues sound familiar? No? You're experiencing different issues? No? Okay. All right, so for those of you who have worked with cloud services, this is really a refresher. What is a cloud service? A cloud service is basically the Windows Azure PaaS offering, which provides you scalability. You own the VMs, you own the environment. You can run N-tier options, and you can run N-tier applications, and it's really like the Microsoft PaaS offering. So if you look at that slide, what it really says is like the white box is a cloud service. Within that box, you have roles. I mean, you're really experienced according to the hands you've shown. And there are two types of roles. There's a web role and a worker role, right? A role is basically just a template for an instance. So when you define a role and say, hey, I want to have a virtual machine size extra large, I want to have like those endpoints, what it really is, it's just like a configuration that ends up in an instance. And the instance is really relates to a VM running on Windows Azure, right? Same goes for worker roles. So why am I showing you this? Because if you think about the entire Azure like infrastructure, everything, right? The diagnostics I'm talking about today is really just in those green boxes, right? And I know that's a problem. A lot of people want to get more insight into the environment. But right now, I mean, we're working on it, but right now this is really where we focus on. But as you will see, you get pretty far with diagnosing things in there. So, like, we have a cloud service, we have web roles, and we have worker roles. Let's look at the web roles a little bit closer. How many of you are using the Visual Studio SDK for .NET, the Azure SDK, basically? You've all created web roles, I assume. Okay. So that left picture should look familiar to you, right? If you create a cloud service project, and what we do is you create a cloud service project, then you choose like what kind of role you want. Let's say you choose a web role, and then you choose any type of web application, for example, MVC4, right? The left picture is what you get after that. What not a lot of people are aware of, that we have one class in that web project, which is here the webrole.cs. It's right above the highlighted one, which actually doesn't belong to that web project, right? That class is really the role entry point for the Azure role environment. So why is that important? I'm going to have a sample and I'm going to show you that. But that's the first big difference. Because now when you build the project and when you package it, right, we can only have one output assembly in that project, because the Azure project is just a configuration container for the Azure stuff. So we cannot have like two DLLs. What we do is we have one DLL, one output DLL, right, and everything in that web project is compiled into that DLL. But then we do something which is really important. During packaging, we stick that output DLL in the app root, which is basically in the package indicates the role environment, hey, this is something you have to do. There is basically the role environment executed in. And then we put that same assembly into the side root. The side root actually ends up being a website, and it runs in the W3 WP process. Okay? Why am I telling you that? So if you set up diagnostics by default, which we already do in Visual Studio, right? We only monitor the W3 WP process, because right now we don't default into a trace listener or a configuration file for the WAIIS host.exe process. Does that make sense? I'm going to show it to you, that then it becomes more clear. But this is a fairly important concept. So think about, you ever want to know, hey, my instance stopped working, right? You want to get a trace that your instance stopped working. Or you have something in the startup, in the role environment startup. You want to install something there, or you want to execute something, and it's not working. You can put as many trace statements as you want into that role entry point class. You won't get anything until you have configured a trace listener. And I'm going to show you how to do that. Okay? So now after that, as I mentioned, let's talk a little bit more about Windows Azure Diagnostics, really. So Windows Azure Diagnostics, for those of you who haven't used it, it's a fairly complete framework that you can use for troubleshooting, for diagnosing, and even for monitoring, right? So you can basically configure it in a way that it collects Windows event logs, that it collects performance counters, and then there are the Azure logs, right? They're the logs in your application. Let's say you want to use system.diagnostics in your web application and want to have this data transferred. That's basically, those are your Azure logs, your trace logs. Then there are the Azure Diagnostics infrastructure logs. How many of you have actually looked into those logs? It's pretty much like a science, right? So understanding those logs. To be honest, what we do internally when we have to look at those logs is really when something with the diagnostics itself goes wrong, right? Then we look into those logs. So for example, your diagnostics data collection exceeds the quota, right? Or the transfer of the VM is not fast enough for all the data that's being collected. That would be shown in those logs. Then obviously it collects IIS logs, the normal web server logs, and then you can also set up failed request logs. So if you wonder why we don't enable that by default in Visual Studio, the reason is failed request logs are fairly expensive, and we want to have the user like you to set it up, right? Because it has like some performance impact. And then you can also use it for using crash dumps and custom logs. So how many of you know how Azure Diagnostics works? Have you ever like looked into it? Okay. So this is an important concept, and I hope that's actually what I was talking about, and I really hope that helps you. So on the left-hand side, think about on the left-hand side of that picture, that's Visual Studio, right? We create a project. In that project, you have a web config for your web project. You have an app config for your worker role or for your role entry point. And then, starting with the SDK 2.0 release, we also put a WAD config file into that role. How many of you are on 2.0? Okay. How many of you have used the new diagnostics feature in 2.0? Okay, cool. So you'll see something new today. So with 2.0 release, SDK 2.0, we basically set up diagnostics for you out of the box, and I'll talk you through that. And the way we do that is through the diagnostics.wat.config file. So because we want to go away from a code-based approach, okay? Then we also, when you create a new project, we also package the diagnostics agent by default. It's always in there. When you publish it and you don't turn off diagnostics in the role designer, we package everything up and push it up to Azure. Okay? So once that goes pushed up to Azure, there is something happening, right? The diagnostics.wat.config file is put into the directory on the VM. The diagnostics agent is actually installed and has been started as part of a startup task and starts like collecting to it. And then the website is also provisioned. But then there's this really important thing that happens is the first thing, think about that as a fresh deployment. You deploy to a cloud service the very first time. The first thing that happens is the diagnostics agent looks in a blob container, which is called web control container. In that container, there is a diagnostics configuration for each instance, right? That's really important. And only if the diagnostics agent cannot find like an instance-related configuration in that WAD container, it looks for the diagnostics configuration file or for your code-based approach. In other words, like the precedence of a diagnostics configuration is always the blob in the WAD control container first. Does that make sense? Okay. As a next step, okay, assuming the diagnostics agent didn't find anything in a bad control container, what it does is it says, oh, wow, I have a diagnostics configuration file, and it reads out the information out of that diagnostics configuration file. So in that file, there's basically a definition, what you want to collect. Do you want a performance counters, what performance counters, sample rate, transfer period, Azure logs, and so on and so forth. It's really your configuration. Okay? It reads the configuration out of the diagnostics VAT config and puts it in the VAT control container. So at that point, you have an entry in the VAT control container. If you do a subsequent deployment and you configure your diagnostics with code or you make any changes to that file in your project system and you deploy your cloud service as part of an update, the changes won't take effect. They're not going to go into effect. Because what's happening is what I described to you, right? The diagnostics agent looks at the VAT control container first and says, hey, I already have a configuration. I don't even care about your configuration right now. So that's one very important concept that you need to understand. Then as a next step, in the web.config file, there's a trace listener defined, an Azure Diagnostics trace listener. And if you use system.diagnostics, trace error, for example, those diagnostics traces are being written by that trace listener into the file system of the VM first. Okay? And then the diagnostics agent says, okay, I'm going to look at all those logs in the file system, and now I know what the configuration is. So for example, I only need the errors for my Azure logs, right? Then it grabs only the errors from the Azure logs and puts it into table storage. So some diagnostics data goes into table storage, for example, like the Azure logs itself, performance counters, infrastructure logs. They go into table storage, and then like the IIS logs, failed request logs, crash dumps, they go into blob storage. Okay? But this is a fairly important concept. All right, and that's basically summarizing what I just said. A precedence, the diagnostics agent really always looks first into the blob storage in that VAT control container. If there's nothing in there, it goes to the next. And some of you probably have written like code in the role entry point in the onStart method to initialize the diagnostics monitor. That's one way. Then it uses that one and uses that configuration. Then it goes on and looks in the diagnostics var.config. If it doesn't find any configuration at all, it applies the default configuration. And the default configuration, just to be clear, the logs, Azure Diagnostics Agent, as soon as it has a valid connection string, it always logs to disk. So all you define in your code or in your VAT.config is really what data needs to be transferred off the VM into storage. Okay. Wow, that was a lot of talk, huh? So now let's have a look at it, how it actually works. All right, so yeah, so now we have a choice. You want to see something like the new Azure Tools SDK 2.0? Nobody has seen it before. That's basically what we're going to ship soon. Okay. That's the second surprise in the happy hour. Okay, let's switch. All right. So this is Visual Studio 2013 Ultimate Preview. And for those of you who have worked with the Azure SDK, I want to draw your attention to the Server Explorer. Kind of looks different now, right? Because we have a huge top-level node in there. And I just give you a quick tour. So now we actually, once it's connected, Visual Studio, we have a very clear structure underneath it and say, hey, those are your cloud services, those are your mobile services, this is your service bus, namespaces, storage, virtual machines, websites. We're not done yet. That's really, I'm remoting into a development machine in Redmond. So that's not the final build, just to mention that. But there is going to be some major improvement. Then, as you all are developers, you probably have multiple subscriptions, right? Let me point out a really cool feature here, too. You can actually say filter services. And look at this. You can actually filter services by subscription, by data center, and so on and so forth, and it will show up. Okay? Come on, isn't that great? All right. That was a short introduction of the new feature. So let's talk about the diagnostics feature. Let's create a new project. And I'm going to create a cloud service project. I just leave it here. It's Azure 1. Create an MVC for project. Hit OK. So I want to create an internet application. And once we registered like 55 NuGet packages, we'll see the application. While we're waiting for the project to finish, we got the color back, right? It's nice. Too much color? So you used to know color now? Yes? Sure.
It creates a WAD control container in our block storage.
So the question was, every time you deploy, it creates a WAD control container in your blob storage. No, just the first time. What it does is it's basically adding a new, if you look at the control container, you have a new XML entry in there, which basically has your deployment ID, your instance ID, and that type of stuff.
Yeah, so I'm sitting here looking at my blob storage, and there's like thousands of these because we've been in production for 3 years.
You have thousands of WAD control containers?
Yes.
Are you pointing multiple projects to the same storage account?
We have tons of stuff.
Yeah, that might
So
be it.
does it ever get clean? Because we're afraid to delete them for fear that they're used. We don't know which ones are used because they're duets.
Yeah, so the question was, we're afraid to delete them because we don't know which ones are used. That's an interesting problem. No, seriously, I mean...
Because there's like, just in the first 15 I look at it, there's 4 that underneath the top folder have our website.
Yeah.
And then there's 3 for our player services and 2 for this. And
Yeah. So it takes a little bit more time. We can take that offline. But basically what you need to do is you need to drill into, like, if you look at the entries in a WAD control container, right, your deployment IDs, your instances and stuff like that, you would need to match it back somehow. So there is no tool for it. Sorry, guys.
So the top folder is deployment IDs, so we could also go look for our current deployment IDs and then just not delete those?
Yeah, sure.
So what happens if you delete them and the role is up and running?
So if you delete them and the role is up and running, that's a good question.
Is he going to use the word screwed?
No, I don't think you're screwed. I think, yeah, I would need to, I really need to think about that. I can't tell you that right now.
Thank you.
But I'll take that offline with you. Okay, so project is created. Everybody see that? Okay. Okay, this is basically the image I've shown you. You have your web project and you have your Windows Azure project, which is basically the deployment project. So now I'm going to show you what we do by default. The first thing you'll notice, if you're on an old SDK, if I open the role designer and I scroll down, we have a new section, diagnostics, enable diagnostics, and that's an extended section compared to like the previous ones, right? So by default, we have the settings errors only. So as I mentioned, enable diagnostics. Diagnostics is turned on by default. We enable errors collection by default. So that means if you're in a development scenario and you F5, F5 is not the right thing because you have the emulator. But if you deploy your service, let's step back. Let's say you create a project, you F5'd it, everything worked fine, right? You have to write tracing statements in your code. Now you publish your service into, let's say, a test slot, right? And now your service doesn't work, right? Up until like SDK 2.0, it was like, oh damn, I forgot to configure diagnostics, right? Now we at least catch the errors on an application level for you, and I'm going to show you how that works. So you're not lost. What we are trying to do with that is really in a development scenario to put you in a situation that even if you forget to turn on diagnostics, as long as you have tracing statements in your code, that you will see what caused the error as soon as the exception is caught. So the other option is all information, and then we also have a custom plan, which basically means you can customize your configuration here. So it's nothing fancy, it's really just a simple UI, but it's basically like a UI on top of a configuration file, the VAT config file that I mentioned before. So in here you can define the log level, the transfer period, and the buffer size. The log level is really the level of data you want to transfer off the VM into storage. So for example, if you set it to errors, we only transfer the errors off the VM into your storage account. Okay? So we have that same thing for event logs. And those are the only two that we turn on by default. It's the errors for the application logs, if you use system.diagnostics, as well as the application level event logs for Windows. Okay. We don't set, and that's a bug here, we don't turn on performance counters, but we will, in the 2.0 release, that's the latest release, we'll give you some smart defaults because we gotten that feedback from the 2.0 release, hey, what am I doing with those performance counters? I don't know how to get started. What are smart defaults, right? So this is the latest build you see, and it has some smart defaults in there. So basically the most prominent perf counters. What we'll remove is basically the 3-minute transfer period because we don't want to incur any costs, right, for that. Okay. Then the other tabs are straightforward: infrastructure logs and log directories. So the other thing I want to point out is this nice little text box here. Because what that really is it says use development storage equals true. And if you look at the connection string section down here, it says update development storage connection string for diagnostics and caching with Windows Azure storage account credentials when publishing to Windows Azure. Nice sentence, right? What that actually means, because we wanted to turn on diagnostics by default, if I took that project now and deployed it to Azure, right, my diagnostics agent wouldn't have a valid connection string because the diagnostics agent would still point to use development storage equals true. But we wanted to turn on diagnostics by default, so we say, okay, once you publish, you need a storage account to put your package in, right? We're going to replace that by that, we're going to replace that token, use development storage equals true, with your publish account. Honestly, I wouldn't recommend that. That's why I pointed out, I would always go in here and pick like a designated storage account for diagnostics data because you want to keep the diagnostics data separate from all your other data. So that's the one thing. And now the last thing I want to point out is the diagnostics configuration file because I talked about that before. So this is the web role, and as a web role content, we actually have the diagnostics file in there. So if you ever want to apply very sophisticated settings and stuff like that that we don't provide you in the designer with, you can go to that file and change that file. Okay? All right, so let's assume magic happens and I developed a project, right? I built a very, very simple application, and this is this one here. And this is the typical problem. Going in here, I'm going to F5 it. It takes a while. So it's using the emulator and storage emulator, and once the website is up, we should be able to see it. And you'll see the very sophisticated coding skills of a program manager. So there it is, awesome app. But it works locally. That's basically the point I want to bring across, right? So you can go in here, see all tasks. Those are all that are done or open, and the ones that are done. You can upload files and attach them to a certain task and assign them to people, right? So bottom line, it works locally. But what happens if I go to that? What happens if I'm going to go to that deployed service? Fast forward, assuming I deploy that service now to Azure, right? The deployment is complete, and now I want to go to that website. So I'm going to hit the website, and for the sake of time, I've already done it here. And as I can see, or as you can see, you're basically getting an error, right? So what's happening now, I haven't changed anything in that project. I just developed it. I used some trace statements in my code. It was working locally, and now I published it to Azure. And as said, it's not working. So what am I going to do? It's a problem for me. So I'm going to go to my cloud service. And in my cloud service node, I'm going to go to that cloud service, build task list 2, as you can see, I practiced this a couple times. So go to my production slot, and here's my cloud service, right? So now, if I right-click on that role, we have two options: view diagnostics data and update diagnostics data. And the update diagnostics data, you like that? Okay, cool. The update diagnostics data is really that's the thing that writes to that VAT control container configuration. So if you update your configuration from Server Explorer, right? Let's say you update it, you want to turn on like verbose data coming in. You update it through Server Explorer, now you found your issue, now you go back to your code, you fix that issue in the code, and you redeploy your project, right? As long as you don't do a full redeployment, it won't override the configuration that you just put in through the Server Explorer. That's something really important to point out. Okay. Also, what's amazing, I think it's amazing here, what we've done is, the update diagnostic setting is available on a role level and on an instance level. That means if you have 4 instances, right, you can go to a particular instance and say, hey, I just want to update a configuration for that particular instance. And then the other instances are not touched, the configuration. All right, let's go and see the view diagnostics data, because you remember we had an error in there. And I'm going to get the data. And as you can see, wow, I have a new page here, which actually gives me an overview, right? Here I know, okay, I have 2 errors in my Windows Azure application log. And probably one of those was caught during that execution. Let's look into it. And if I read this, and read it all the way to the end, you can see the connection string is not correct. I should make sure, because it's pointing to a database which is not there, right? So I at least have a pointer now to know, hey, what went wrong? Why did it work locally? Why didn't it work there? And that is there out of the box. So that's, you don't, except writing your trace statements in the code, we'll show you that, okay? So let's take it one step further here. Because in that page, we only show you the data, the errors. It's really just the errors. Because we want to put you in a situation as a developer that when you run into an error, you can go to a page and you get a snapshot. Hey, what went wrong, right? We don't want to spam you or we don't want to show like gazillions of lines of tracing data, because you're really interested in the errors first. And then you can basically try to find the causality. So let's say you want to look at all the diagnostics data here, which are in your application logs. You can go to view all data. And what we do here is we basically link to the storage account that has the data in there. That's unfortunate error here. That's the error we had, right? But what we can do is now, with those releases, 2.0 and 2.1, you can actually go in here and select the query builder. So if you have a lot of data in your storage account, you can go in there and say, hey, I want to filter, and now not just on partition key, row key, and timestamp, because that's what the normal or the standard storage tools filter. No, we also allow you to filter on the date and time, and that's actually the date and time when the error was locked, because the timestamp is really when the error was transferred, right? So we kind of convert the ticks that are in the partition key into date and time. You can filter by deployment ID, role, and role instance, and role level. Okay. So the next thing I mentioned before is really the role entry point, right? So this is a web project, and I have a webrole.cs, and in my webrole.cs I wrote some code. So in here I basically wrote some trace statements. I'm basically getting like status information. It's just a status check. It's telling me, hey, is my instance ready? Is my stuff up and running? So why I'm pointing this out, if you just go in there and put those trace statements into that role, as I mentioned before, it doesn't do anything. What you really need to do is you need to add a configuration file for that process. And that configuration file, which I highlight here, has the definition of the Windows Azure Diagnostics trace listener in there. That makes sense? So another important point to point out is really what you need to name the configuration file. It has to have the name of the output assembly of the project. So for those of you who have used like Azure Diagnostics before, you may have used var.is.exe.config, right? That doesn't work anymore. You really need to name that configuration file with the name of the output assembly. Okay, so let's get back to the slides.
I think I've used app.config before. It actually works. It changes the name.
Yeah, app.config would work too. Yeah, that's true. But the var.is host.exe.config doesn't work anymore, unfortunately. All right, so again, that was like a deeper look into Azure Diagnostics. There are a bunch of key considerations to summarize. So first of all, the Visual Studio contains the diagnostics agent by default. That basically means if you don't go to the role designer and if you don't uncheck enable diagnostics, we'll take that thing, publish it, and then it's up and running. If the diagnostics connection string is not changed in the role designer, as I've showed you, we're going to use the connection string for your publish operation. If you want to trace failed requests in your web role, you need to actually add the failed request statements to the web.config, so we don't help you with that in Visual Studio. You need to add the configuration file for role environment diagnostics. That's what I just talked about. And then, if you use the var.config or if you use the diagnostics monitor, a full redeploy is always required after you made some configuration changes, because the full redeploy will basically override the VAT control container entry there. Okay? So that's a common thing that people have done some configuration, the configuration is up there, and then use Visual Studio to deploy the service again. And we default to an update deployment in Visual Studio, right? We don't do a full deployment by default. We always do an update. And then people are wondering why the new diagnostic settings aren't applied, and this is really a reason. Yes?
Can you just pick re-image or restart on an instance out of the redeploy?
No, it has to be redeployed. The question was, can you just restart or re-image on an instance? It needs to be a redeploy. I'm fairly confident. The thing is, I mean, if you think about it, it's not that bad, because I don't think, how many of you are using Visual Studio to deploy into a production slot? Oh, really? Interesting. That's good feedback. So, there are some hands, okay? Yeah, that might cause an issue there. Okay, so, but now the new tools give you the opportunity. You can use Server Explorer now, right? You can basically revert it. You can avoid a full redeploy if you use code by using the role instance diagnostics manager. That's a class that you can use, and that wouldn't require a full redeploy. The tracing strategy, if you put in your tracing statements, can be tested locally, because all the data is also, or the same data, the VAT control container, and the tables are created in a storage emulator as well. Okay. So next thing I want to talk about is IntelliTrace. How many of you are actually using Visual Studio Ultimate? Majority. Because IntelliTrace is actually an ultimate feature. The reason why I bring that up is it's a lot of you might have an MSDN license, and IntelliTrace or the MSDN license allows you to use Visual Studio Ultimate as well if you have the right license. And it's really great. It's basically a flight recorder of your application. How many of you have used IntelliTrace locally in projects? All right. So what it does is it basically records the execution of your program. all the calls, all the events in your program, right? That's particularly great because you turn it on, you publish it to Azure. It's basically an agent that is being published to Azure, and then it starts recording the execution. And let's say now you run into a logical error with your application. You can download the IntelliTrace log and basically start debugging it. It's historical debugging. It's really great. And the good thing about it is all the stuff I just told you about, WAIS, host.exe, those two different processes, right, in the W3, WP in a web role, it also captures like both processes. There is nothing that you need to set up for it. Okay? It's great for chasing down logical errors, and I hope I can show it to you now because I had some network issues today. And then it's also great for detecting missing assemblies. Way back in earlier releases of the SDK, we always had that problem that you as a developer, you reference something in your project, let's say an assembly, the assembly wasn't on the VM or on the cloud service, you published it and it didn't work, right? So a last call troubleshooting option has always been IntelliTrace. But now, I'd say with the 1.8 release of the SDK, we've gotten pretty good in detecting missing references. The catch, though, is you usually often already published it because we show those missing dependencies as a build warning, which usually comes up after that. But think about it. If you have a project, if you reference assemblies, I would try like building it first, package it first before you deploy it, because then you usually get like build warnings. And it says, hey, your packaging or your project relies on an assembly that's not a part of the package or that's not up on the VM. Okay. So the way the IntelliTrace agent works, it's kind of similar to the diagnostics agent. In Visual Studio, and I'm going to show you that in a second, you basically publish your project, you select IntelliTrace, you make some adjustments to IntelliTrace, what you want to collect. Let's say you just want to collect events or calls, right? So you basically configure the IntelliTrace agent and then you publish it to Azure. So once that thing is installed and your role is up and running, the IntelliTrace agent basically goes in there and creates an agent queue in Azure Storage. Okay? And the agent queue is being used to, by the IntelliTrace agent, it says, hey, do I have a request? Do I have a request from Visual Studio? So it's polling the queue. And it's polling the queue every second. Why is that important? If you decide to try out IntelliTrace, right, and let's say on a Friday afternoon, think, hey, I'm going to deploy that, I'm going to turn on IntelliTrace, and I'll see what happens on Monday, you get like a transaction every second, right? That's something to keep in mind how it works. That's really internals. Then in Visual Studio, the developer says, hey, I want to look at my IntelliTrace data. Visual Studio puts another queue into the Azure storage account. And then it says, hey, I want to get the logs from IntelliTrace. So it puts a state in pending. It creates a snapshot, which basically starts executing the actual IntelliTrace agent. The IntelliTrace agent starts collecting and started collecting, it puts an iTrace file on a VM, right? Then it gets the command, hey, please, it's done, snapshot is done, please upload it to the blob. Then the iTrace file is being transferred to the blob container, deleted from the VM, and once the transaction is completed, it's being returned to Visual Studio, and the iTrace file is deleted. Okay, so that was a lot of theoretical background. Now I'm trying to show you this. Let's switch machines. So I already deployed an application a while ago. It's a Fabric and Fiber call center. If I look at the application itself, let's go through it. Yes? You have a certain amount of storage for the storage. The question was, are we charged for the storage account? Yeah, so the question was if the RAD control container, the blob, and the table storage, if that's something you have to pay for. Yes. So it's basically part of the storage. So once I need to go here. All right, so that's the application, and that is supposed to be me. Let's look at the customers, right? Because this is where really my tester told me, hey, we should look at the customers. Something's not working right. So I'm looking at the customers, and here's the customer list. And now I want to add it like the first entry, right? Added Maria, and I'm getting Antonio. It's kind of weird, right? So going back, trying it again, trying to get Patricio to edit him, and I get Janine. So apparently something's wrong in the code, right? Something's not working right there. So how do I troubleshoot that? You probably don't have like tons of trace statements in there to really trace through, right, what actually happened there. And IntelliTrace is really the thing that can help you here a lot. Let's go to the application. As I mentioned, I already deployed it. And you can see if IntelliTrace is deployed or Profiler is deployed. You can see it in the storage, in the Server Explorer, right next to the production slot, and it says IntelliTrace. That basically means IntelliTrace is enabled for that. Let's go drill into that role, go to the instance, and then you see on the right-hand side in the context menu, it says view IntelliTrace logs. All right, let's try it. And what's happening now is it's actually the request I've just described in that diagram, right? Visual Studio said, hey, I want the logs for debugging. Right? So now the logs are being transferred. It's actually that the iTrace file is coming to Visual Studio. And because I deployed it right before the session started, because I didn't want to have you watch the deployment time of 4 minutes, takes a while.
You have half a dozen instances. Do you have to go on an Easter egg hunt to find your IntelliTrace file?
Yes, so the question was if I have like 6 instances, if I need to go to the instance to find the IntelliTrace. So the IntelliTrace agent and the listener, they are deployed to the instances. So you would need to go to each individual instance. All right. Yes? So the question was if there is no way to disable IntelliTrace on demand, or? Yes, without a redeploy? Yeah, so the question was if there is a way to enable and disable IntelliTrace without redeploying. Not yet. Okay. So right now it requires a redeploy. We're working on something to basically enable you to just turn it on demand. Right? Okay, so IntelliTrace file is here. Let's see if we get it. So I can go to the web requests. Here's the web request list, and I know I was looking for customers. Let's go to customer, and let's search for it. And here are my web requests for the customer, and here I can see the added commands going to the controller, right? Let's pick one and say I want to request details for that control. So now I'm getting all the details that happened when that request was executed, right? So let's scroll down. This is the event list. Let's scroll down. I can see, okay, there was customer edit, and then I have ADO.NET execute reader. So, which basically means, hey, the data should come out of the database. There was a database call, right? So now I really want to know what was going on in my code. I can actually go in there and say start debugging. And it's loading the symbols, and I'm jumping right into the code where actually the call was made, right? It gets even better because now I'm in my load from cache. I mean, hey, I want the customer, it was executing a query from the database, right? Where has this load from cache been called? So I can actually start walking the stack trace here, right? And see, hey, what's the chain of events? What actually led to that load from cache, right? the other one. And then you can even see here, if you look at variables, for example, you can even see like the values, right? You can go to the locals and you can see actually exactly what was going on, right? So is that cool? I think that helps a lot. All right, so that was IntelliTrace demo. I hope you enjoyed it. Again, it's a very powerful tool, and I think in a dev environment, it's still okay to deploy it, but again, we're working on a solution that you can enable it on demand. I mean, that actually will enable the full power, right, of it. Okay, let's go back. The next thing I wanted to talk about is the profiler, right? Profiler is the same approach. You would actually go to your project, and you know what? Let me actually show you that. It's probably better. Stop debugging here. Say I want to publish my application in the Publish wizard. If I go back, go to the advanced settings. Here you can see enable IntelliTrace and enable profiling. Okay, so both are mutually exclusive. So you can only have IntelliTrace or profiler running. That's just because the CLR limitation of having two profilers running at the same time. But that's basically how you would enable it, right? And in profiling, you can actually go in here and you can decide what kind of profiling you want to do. If you want to do CPU sampling, instrumentation, memory allocation, and concurrency. What's actually really cool about that feature is if you have a ADO.NET based data source, or if you access a database source through ADO.NET, you can actually turn on tier interaction profiling when you use instrumentation. And what that does, it really measures the time of execution. So for example, I have another, in the sake of time. So think about you deploy your application to Azure, right? You hit your website and it takes a long time. And now you want to know, hey, what's taken so long? And assuming you have a SQL Azure database, right? Once you have turned on the profiler and tier interaction profiling, it's exactly the same mechanism as with IntelliTrace. You actually go to Server and Explorer and say, hey, I want to see my profiling logs, right? Then the profiling report is being downloaded, and then you can actually see in your entire execution of your program what kind of action took the longest. And if you have turned on tier interaction profiling, it even shows you how long the execution of stored procedures or calls on the database took. So if you have like a database which wasn't developed by you and there's some SQL statements in there, or you have some stored procedures and they're not like performing that well, you can analyze that with a profiler. Okay. So again, if you choose instrumentation, it really records how long every method takes to execute. That's what I just explained. It's really useful when the app is slow. I mean, we use it internally because we have some internal services as well, and it's really helpful. If you have a lot of short-running functions, it may impact the performance, but that's, I think, okay because you're troubleshooting anyways. And the problem is, as it records everything, if you let that thing running for a while, right, it can really produce a lot of logs, right? That's also you need to keep in mind. Then sampling, on the other hand, is very lightweight. It's very useful for identifying inefficient algorithms. And the other feature is the TIP, tier interaction profiling feature, which actually the profiler is available in Visual Studio Pro, but tier interaction profiling is a premium feature. So if you have Visual Studio Pro installed in the Azure SDK and you want to publish it, you won't see that enable profiling if you're just on Pro. You won't see the tier interaction profiling option there. It's just not there. Okay. So in the sake of time, I'm going to skip the profiler demo, but I'm going to be at the booth tomorrow. If you're really interested in the demo, I'm going to show it to you because it's actually quite interesting. So cloud services, IntelliTrace, and profiler, things to keep in mind is really concurrency of agents right now. Because you cannot have like multiple CLR agents running at the same time. Why am I saying that? So there are really great third-party tools out there for CLR profiling, like New Relic and things like that. Those are really great tools, right? And you can enable them through the portal. And let's say a profiler is already enabled. Right now in Visual Studio, we have no way of detecting that. So we would actually, if you turn it on, we would package it, would enable it, and publish it to Azure, and then it would crash, right? Because you cannot have two at the same time. It's just something to keep in mind if you use like those tools and you want to enable IntelliTrace or profiling in addition to it. So the polling interval, and that's nowhere documented. You can change that second polling interval that I was showing you. You can actually change that. And you need to go in your development machine. You go to C program files, Windows Azure Tools, Visual Studio, like in that particular case, version 11, which is Dev 11, and then to the SDK release folder, VS Diagnostics, and then there is a file which is called Windows Azure Diagnostics agent.exe.config. And you can actually override the polling interval in there. Let's say you wanna have a longer running operation and you don't want to like hit your storage every second. You can do that setting in that file and then deploy it again, and then it's taken effect. Okay. All right, so Cloud Service Diagnostic Summary. What we offer you in Visual Studio, we offer you, I think, the tools for multiple things. For if you have environmental differences, like let's say emulator or staging environment versus production, can use Azure Diagnostics. IntelliTrace is also a good tool of choice to catch those errors. If you have performance issues, you can use Azure Diagnostics as well. I mean, it requires some settings for performance counters, and you need to know what to monitor. But you can also use the profiler, right, as I just explained to you. If you have logical issues in code, yes, if you have to write tracing statements in place, you can use Azure Diagnostics or semantic logging or any of those tools, or IntelliTrace is also really helpful there. Okay. So in the sake of time, I'm going to quickly show you the Azure Website Diagnostics, talk you through that. So Azure Website Diagnostics works similar to Cloud Services Diagnostics. So you can differentiate between site diagnostics, which is actually detailed error logging, failed request tracing, and IIS logs, right? It's basically the logs you also get through Azure Diagnostics, but on an Azure website. And then, of course, the application diagnostics part. The application diagnostics really refers to the application itself. That's basically you write a web application, you put your trace statements in there, and you publish it to an Azure website, right? That's the application diagnostics. So it works similar to Azure Diagnostics. You just need to use the system.diagnostics namespace and then trace.trace error or trace.trace information. But the key differentiator here is you don't need to do any configuration whatsoever. I mean, I mentioned in Visual Studio for cloud services, we help you. We put a configuration in there. But for websites, you don't have to do anything except writing your trace statements. And then you're already wired up for diagnostics. The diagnostics configuration, you can enable them from a bunch of things. For Azure websites, you can enable the diagnostic settings from the portal and Visual Studio Server Explorer. You have the same logging levels as you have in Azure, and you can store the data in a file system, and then it can be accessible through FTP downloads. You can basically download the logs, or you can store the data in a Windows Azure Storage account. If you store this data in a Windows Azure Storage account, it's pretty much the same concept as Windows Azure Diagnostics for Cloud Service. It's actually going to store the data in a table. It's called VAD logs. And, Windows Azure Websites app log table, which has pretty much the same schema as the Azure Diagnostics table for logs. And then a really cool feature is streaming logs. So you can actually live stream your logs back into Visual Studio. I don't know. Have you seen that? Have you heard about it? Okay. Quick the architecture. You have your web app. Everything works. And then there are two trace listeners. And the trace listeners are defined on a machine-wide configuration. So the Azure Drive trace listener writes the trace statements, the systems.diagnostic trace statements to the website drive. It's basically like storage. You have a table listener. If you configured it for Azure Storage, it writes it to the storage account. And you can enable live tracing through Kudu log streaming. And that's what I'm going to show you now quickly because that's really cool. Let's switch back here. So, okay. So in my new shiny Server Explorer, I have a node that's called Websites. And I already created a website. It's called Build Task List. And then if I open the website in browser, I can see it's a similar website to what I had. I have my tasks, all tasks, and I can upload large lists. So let's try that. Let's see, be shown. And then try a file to upload a file. Let's use this one, upload it. Well, something went wrong, right? So in that particular thing, I can really go in here. Let me just open a new instance of Visual Studio to open that project. While it's opening, I can go in here. So this is the project that I deployed through Web Deploy. That's the task list we've just seen. Go to my website folder. While that's loading, okay, so now in my context menu, I can say View Settings. In the Settings page, I can actually adjust some configuration settings for diagnostics. So I can basically say, hey, how should it behave? So for example, for application logging, I can say I want to have verbose data, right? Failed request tracing, you can turn it on and off. Detailed error message, you can turn off. Web server logging. But then you can also say, hey, something went wrong, right? I just want to view my logs in the output window. So you turn on live streaming. We're going to go back to the web page. Try all tasks. Still works. Go back here. Try to upload a file. Okay, upload it. And then see what happened. And there's the output. As you can see, okay, first I hit the task. I got all 5 tasks because I set it to verbose. So my tracing was, hey, I have 5 tasks. But then when I tried to upload it, I actually ran into an error. And the error says, hey, no valid combination of account information found. So something's wrong with my storage account when I want to upload it. But the cool thing, really the takeaway for Azure Websites is it has like similar options as Windows Azure Diagnostics, and it also provides it with live streaming, and that's a really cool feature thing. So the question was, are there any future plans to make that available in cloud services? Let me ask you one question, and that's, I think, for the bigger audience. What do you think is more useful, a debugger for a cloud service or live streaming? See, so you guys want to go for both?
Well, live streaming is cheaper than the debugger.
Cheaper in what sense?
Well, I guess if you use IntelliToys.
Yeah. No, I was talking about real debugging. Let's say you have a web roll up and running, you have a website, right? That thing runs, and then you just start a debugging session. Not even IntelliTrace, really live debugging. Yeah. Okay. Yeah, so you guys, if you like to have something like that, find me tomorrow. I'm at the booth. Okay. Let's go back to the slides and ramp up. Sorry, we're running a little bit out of time. So the last thing I mentioned at the beginning, this morning at 11 a.m., we released, I almost called it a SKU. We released what we call internally a developer desktop. And what that actually is, it's a Windows Azure image. It's available in the gallery. If you go to the Windows Azure virtual machine gallery, it still has a very weird icon. It has a Windows icon, so the Visual Studio icon will come on later. But there is an entry which says Visual Studio Ultimate 2013. You've already seen it? Previews. So what that is basically our, what we call developer desktop. And what we're trying to do here is we try to enable MSDN users to quickly spin up dev test environments. So with that particular image, you can provision it from the portal. The image has IS Express on it, and it also has SharePoint Trial on it. If you provision it from the portal, you can remote desktop into that image. On that image, we have a bunch of scripts that basically provision SharePoint for you or provision SQL Express for you if you just want to use it for web development. So it's a multi-purpose development environment, if you will. In addition to that, we also released a bunch of scripts that allow you to provision that developer desktop entirely remotely through PowerShell. So you can basically, let's say how many of you are SharePoint developers or working with SharePoint? Okay, once. So SharePoint, as you know, like for full-blown SharePoint development, you need a proper AD, right? The scripts we released is they will create you an Azure VM with Active Directory on it. Then the other script will create a virtual machine of that image and join it to that domain, and then configure or provision SharePoint. So you're ready to go after that. And then you can basically start developing. If you just want to do web development or any type of development, you can just provision it through PowerShell remotely and it will work. And again, the image went live this morning at 11 o'clock. You're supposed to have an MSDN license because as soon as you've provisioned it and you launch Visual Studio 2013, it asks you to sign in. That's the new sign-in feature. But then you're good to go. And that's the screenshot with the icon that we didn't ship. Because, again, as I mentioned, it has the Windows icon. So that screenshot is not quite accurate. All right, so that was pretty much it. I know there was a lot of content to put it in a 1-hour session. I still hope you got some information out of it and it will help you doing like further diagnostics. And I'm going to be around the booth tomorrow if you have questions or if you want to discuss diagnostics approaches or develop dev test approaches, as we now call it. I'm more than happy. I'm actually looking forward to talking to you about that stuff. Okay. With that, I'm done. I also need to remind you that if you go to the hall, to the big hall, there are like some giveaways available. Okay? And don't forget to fill out your evaluations. Thanks.